learning about elements, and I found out that each element could have up to 8 valence electrons, and then I was shown this representation of arsenic. I just didn't understand. There was a different amount of electrons in each little ring that were arsenic. I just didn't get it. That's what I'm here to explain today. Orbitals. And orbitals are actually a probability of area or space where an electron can be, because we honestly don't know where the electrons are. We can't really predict where it's going to go, but what we can predict is where it will be approximately in terms of area. And it's actually not a circular orbit like most people think. And so here in the periodic table, we have the s orbitals, the p orbitals, and the d orbitals. And helium is here, and it's actually an s orbital, but because it is a noble gas and it fulfills its complete orbital, it's in the noble gas side. So yeah, so the p orbital looks like a sphere, like a ball, and it can hold up to 2 electrons for each s orbital, and there's 1 s orbital in each energy level. Then we have the p orbitals, which are over here starting with boron, and those kind of look like 2 little lobes, and they are in the x, the y, and the z direction. And each p orbitals can hold 2 electrons, 1 in each lobe, for a total of 6 electrons. The d orbitals is where it gets a little more complicated with the s and the p orbitals, but it still follows pretty much the same rules. So here we have the d orbitals, and there are 5 d orbitals as shown here, and each little thing of d orbitals can hold up to 2 electrons each, for a total of 10. Actually, one weird thing with the d orbitals is that it actually starts in the 3rd energy level, even though it's right next to the beginning of the 4th energy level with potassium. So here, this is the first s orbital, and the second s orbital, and the second p orbital, the 3rd s orbital, 3rd p orbital, then we have 4th s orbital, 3rd d orbital, and then 4th p orbital. So that's why this representation of arsenic is correct, because we have the first s orbital filled, the second s and p orbitals filled, and then we have the 3rd s, p, and d orbitals filled, and then we have here 2 s orbitals filled, and then 3 additional p orbitals. Thank you so much for watching this explanation of orbitals.